Hello and welcome to today's session on prism. Today we'll solve a couple of problems related to prism, especially looking at the minimum deviation and other deviation in which we are interested in. So if you remember our last session, we proved that if we have two prisms like this and the ray of light is coming, in case of symmetrical passage of light, the deviation is minimum, right? So we use some calculus to prove this. So if the ray of light was actually coming like this and passing symmetrically to the prism, the deviation turns out to be minimum, right? So symmetrical passage of light through the prism gives you passage through the minimum deviation. You can check out that proof which we did using calculus in our last video. Now there are things which I want you to repeat and basically understand again so that we can solve problems related to this, because a lot of questions in the exams is going to come asking for the minimum deviation and we should be able to calculate that. Okay, pay attention, we'll be able to solve those problems pretty easily. So when a ray of light is actually passing through a prism symmetrically, we know that this angle is now going to be equal to theta by 2. Okay, and by symmetry, basically angle of refraction here and angle of incidence here is going to be equal, right? So this is beta 1 is going to be equal to beta 2 and this will be equal to beta. And we also proved that in that case this beta is also equal to theta by 2. Okay, so with that in mind, we can simply write the equation and of Snell's law. And again, by symmetry, this here we know that angle of incidence alpha 1 is going to be same as alpha 2, and that is alpha. Okay, now assume that this prism is immersed in a medium with refractive index Nm and the refractive index of the prism is Np. Okay, so we can write Snell's law. So here the ray of light is coming, then it's coming parallel, and then it is getting deviated, and this is the minimum deviation, right? And so deviation, as we write earlier, was a very simple equation which we said the deviation is nothing but alpha 1 plus alpha 2 minus theta, right? Now we know that the alpha 1 and alpha 2 is equal to alpha. In symmetrical case, it is 2 alpha minus theta, and that's what we'll remember and plug back in when we need it, right? So now let's write Snell's law here. So we have coming from this angle in the medium Nm, at point, let's call it A. Okay, so Nm, which is the refractive index of the medium, into sine of alpha. Okay, is going to be equal to, this is beta, sine of beta multiplied by refractive index of the prism. Okay, that we know. And finally, for solving this, we arrived at a very simple equation. So sine of alpha, sine of beta, np. So this will be equal to beta is nothing but theta by 2, and alpha is going to be equal to, from this equation, alpha is going to be equal to delta plus theta by 2. It's going to be alpha. Now, so now we can write an expression which I will like you to remember, or you can derive it whenever you like. It's a very simple equation, right? So we have refractive index of the medium multiplied by sine of delta plus theta by 2 is going to be equal to refractive index of the prism multiplied by sine of theta by 2. And this is in case of minimum deviation. Okay, so whenever the question says calculate minimum deviations, we can simply calculate here this delta mean by using this formula, and that will make our life easier without applying maximum minima and wasting our time. So this is a very important equation, and with this in mind, let's start with a problem to this. Now suppose we have an equilateral prism here, okay, which means that the angle of prism is basically 60 degrees, okay. So we know the apex angle A, or this is theta, right? So theta we know is 60 degrees, okay. And it says that the ratio of refractive index of the prism divided by the refractive index of the medium is given to be 1.69, okay. And also, just what sister saying, sine inverse of 0.845 is equal to 57.7 degrees. Okay, so we can use that if required, and we are supposed to calculate the minimum deviation. So whenever the question is asking for minimum deviation, we can straight away write this equation and try and solve it. Okay, so let's write that down for this situation. We know that theta is 60 degrees, and we can write the equation. Now Nm, which is the refractive index of the medium, so we don't have the exact value, but we have a ratio. So Nm into sine delta, that is what we want to find out. Theta is 60 degrees. 2 is going to be Np sine of 60 degrees by 2. So simply put Np by Nm, so I'll take it on that side. So sine of delta by 2 plus 30 degrees is going to be equal to Np by Nm sine 30 degrees, and this will be equal to 1.69 into sine 30 degrees, and this will be equal to 0.845. That's why probability is given over here. Now we'll need a sine inverse on this side. We can simply solve for it, so it will call sine inverse of delta by 2 plus 30 degrees is equal to sine inverse of 0.845. We know this value is provided here is 57 degrees roughly, right? So now we can solve for our delta, and delta will turn out to be 55.4 degrees, right? So let's look back at the equation and what all interplays here, and in that way we'll be very clear on how we can use it. We'll need the refractive index of the medium. Most of the time, if it is in air, this is going to be 1. We'll need to find out the apex angle of the prism. Sometimes using geometry, sometimes it is given. So here we use geometry like it is equilateral triangle, so it is 60 degrees. We need the refractive index of the prism, and then we are done. So only 2-3 variables, Nm, Np, and theta. So if we have this information, most of the time it is 1. So Np and theta, and then we can find delta by plugging in the numbers. Okay. So let's take another example. So I'll say what is the smallest refracting angle that a glass prism with refractive index n is equal to 1.5 can have, so that no ray can be transmitted through it. Now, as you can see that it is not a very simple problem, but we have slight complication coming in here, and this is how you can create problems like that. So now let's see what we have got, right? So we have got, saying we have a prism, okay, and we want to know the refracting angle of that prism, right? So we have a prism here. We want to know this angle, usually the apex angle, the refractive angle of the prism, which is theta. Theta is not known, and we know that it is in air, so n of m is, the medium is 1, and n of p is 1.5. And now it has given us a condition which says that what is the smallest refractive angle that a glass prism can have so that no rays can be transmitted through it, right? So delta is not given, not known. But can we find delta from this condition? Now think about it. So if the ray of light is basically coming like this, okay, and it's get deviated by 90 degrees, okay. Let's say on this surface, right? So this is a prism surface, and the ray of light is coming at a particular angle. So let me the surface, right? So, so the ray of light is coming like this. Sorry, to get reflected here. So assume that from inside it is coming like this, and now we have a surface. It will get refracted. Now, if it get refracted, or there is a change of direction, that is delta is more than 90 degrees, basically we'll have total internal reflection, right? So if this change in delta is greater than 90 degree, basically the no ray of light will pass through the prism, but it will get reflected at all other angles, right? So the no ray of light is getting transmitted. We can say that in the case here where no ray of light is getting through the prism, which means that ray of light was coming like this initially and then possibly bend inside, hence this delta is greater than 90 degree, and this is the critical angle, right? So for a particular critical angle this will happen, and then delta is 90 degree and we'll have total internal reflection, right? So we can assume that delta is, in that case, no ray of light will pass through because of the total internal reflection. Now, so now we can solve this pretty easily. Now we have our delta. So delta is known to be 90 degrees. We know the NP, we know the N1, and we have to find theta. So let's plug these numbers back into our equation, which again I'll write it down so that you remember. So it is going to be very simple. NMM into sine delta plus theta by 2 is going to be n of prism sine theta by 2 in case of minimum deviation. This is 1 into sine delta is 90, theta is unknown by 2, n of p is given 1.5 into sine theta by 2. We can do some simple trigonometry here, and basically we'll end up, you can simply write equation like that in many steps. You can try it and solve it yourself as well. So this is sine 45 plus theta by 2 is equal to 1.5 into sine theta by 2, right? We can write it sine 45 into cos theta by 2 plus 45 into sine theta by 2 is equal to 1.5 sine theta by 2, and when you do all that, end of the day you will find that one unknown theta is going to be equal to 84 degrees. Okay, so that's our answer. So just by knowing and figuring out which all variables we know and where we can apply our equation, we are able to solve this problem pretty easily. So remember that if we didn't knew this equation, we'll have to do maximum minimum. That is going to take a lot of time, and we know that just by knowing this equation and how it behaves, which all variable we have to plug in, now we are quickly able to solve the problem. So now let's move to the next one, where we say that the minimum deviation for a prism of refracting angle 40 degrees is found to be 33 degrees, 33 and a half, sorry, 33 and a half degrees. Find the refractive index of the prism. Okay, so the moment we see it is given the minimum deviation, right? So minimum deviation is given, and we just have to find the other way around. So usually the refractive index is given, so we know it is a minimum deviation case, so we can simply write our equation and see what all is provided. So this is n of medium sine delta plus theta by 2 is going to be n of prism into sine theta by 2. Now let's see. So here minimum deviation for a prism of refracting angle 40. So this is theta. Okay, theta is given. This is here, this is here. And the minimum deviation is found to be 33 and a half. So delta is again given 33 and a half. So we have this one. Find the refractive index of the prism. So the prism is assuming to be in air. This is also given is equal to 1, and we have to find this one. Okay. Simply plugging back the numbers in here, we can write, rearrange it a little bit. So we need to find n of p. So we'll say n of p is going to be equal to 1 into sine of delta, which is 3.5 plus theta, which is 40 divided by 2. It's going to be equal to sine, and theta is 40 by 2. And then it's very simple trigonometry, and you will arrive at a number 1.73, and that will be your answer, right? So whenever you see minimum deviation, try and use this formula. It will make your life very, very easy. Okay. Now let's pick up another one. So we say a prism of an apex angle 72 degrees and refractive index 1.66 is immersed in water of refractive index 1.33. Find the angle of minimum deviation. Okay, so here we have a prism. Its apex angle is given, right? So as I said, this angle in the prism has different names, right? So this angle has a different names. It's called apex angle, it's called refracting angle, etc. Right? So here the apex angle is 72, which means theta is 72. We know it has a refractive index which is n of prism 1.66, is immersed in water, so n of the medium is 1.33. We have to find delta. Okay, very simple. Let's write down our equation. N of m into sine of delta plus theta by 2 is going to be n of the prism, right, into sine of theta by 2. Plug it in, all of them. 1.33 sine of delta is what we have to find, and theta is given to be 72 to 1.66 into sine of 72 by 2, and we can simply do a very simple trigonometry and we'll arrive at our answer. In this case, it is going to be 22 degrees. Okay, so as you can see, sometimes the variable will be clearly given, the known ones. Sometimes you have to do some trigonometry to find out. So let's do another problem which is very interesting. So now we have an equilateral prism, right? So it means that both sides are equal, but we are interested in the angle. So we know that it is going to be 60 degrees. Okay, so all the angles 60 degrees. So whenever there's an equilateral, we know our theta is given to be 60. Okay, it has a refractive index 2. Okay. Now we have to find minimum deviation delta and also plot the path of the ray. Okay. So it is in air. Okay. So n of m medium is 1. So let's write down our equation here very simply. N of m into sine delta plus theta by 2. It's going to be n of prism into sine theta by 2. Theta is known, n of m is 1 into sine delta plus 60 by 2. N of p prism is given 2. Yeah. Into sine 60 by 2. And now it's very simple. When you solve that, basically we'll find that delta minimum is 120 degrees. Okay. Now what it means? As we discussed earlier, if the ray of light is coming in the prism like this, right? It has refraction and all, right? And meets at two surfaces, there is refraction. And now this deviation, right? So it is more than 90 degrees, which means that there is total internal reflection happening and the prism is sort of reflecting it back, so that this angle is now 120, right? So we are going to sort of plot the ray of light like this. Now the normal light getting reflected. This is the original angle. This is the refractive angle. And this angle here is 120. Okay. So remember that it is quite possible that a ray of light will get reflected, totally reflected at a particular angle, and in case of minimum deviation also we can relate that. Okay. So this was the point. These are quite a good questions. So now let's move to another one which we have already seen, but in a different way. So this was taken up in our last video where we said we have two dispersive prism with apex angle A1 60 degrees and A2 is 30 degrees. They are grouped together and their refractive index varies with lambda or wavelength. We said that, and we calculated finally the angle, lambda, for which the ray of light will pass after deviation from here, pass straight here, right? So there is no deviation, which means that the refractive index N1 is equal to N, right? So we did that, and by doing that we found that refractive index N at lambda naught was 1.5. Okay, so if you missed this, basically go back to our last video and where we have proven that. Now the question is, if I ask you to find the minimum deviation of this set of prism given this condition where a ray of light lambda naught is passing, right, such that your n lambda is 1.5, you have to find the minimum deviation of the system. Now when you will think like that, basically we'll see, okay, there are two prisms and now what to do and things like that. Now look at it. First thing first, we have this prism here. So let's take it down. Okay, so we have this prism here. Okay, prism A, and then we have another prism here, two prisms. Okay, and as we said, the ray of light is coming at an angle, right? Will get reflected, towards here, and then it is passing straight. Okay, so this will pass straight because there is no refraction here, because the angle of the refractive index of N1 is equal to N2, so no refraction here. Now we have to find the minimum sort of deviation. Okay, now so in that case you can actually think this system as a single prism, right? So if you sort of think like that, basically what we have is, this is the same glass, right? So you have a prism like this. Okay, and the question reduces to simply finding this apex angle. Okay, let's call it A, right? And then we know so now what we know? We know the refractive index, which is 1.5. Okay, refractive index of the prism, refractive index of the medium is 1. These two we know. Theta, if we can find out, theta is A, then we can simply write the equation and find the minimum deviation. Okay, so this was a trick that you have to use. So you have to be aware of this and try it out yourself. Now, to find A, let's do some simple geometry, and hopefully we'll be able to find A pretty quickly here, right? So they said this is 60, okay, this is 30, this is 90, so this will be also 60, okay? Sorry, 90, 60. Sorry, this is 30. Yeah, this is 30. So this angle will be again 60. This is 60. And this two put together has to be 180. So this will be 60 degrees. This is 90. So A is equal to 30 degrees. Okay. Now we can simply write our equation and we'll be able to solve this problem very easily. So what is our equation? Very simple. We know that. So it's like refractive index of the medium, sine delta is what we have to find out, plus theta is 30 degrees by 2 is going to be equal to end of the prism, which is 1.5 sine 30 degrees by 2, everything known. We can simply find this one is 1, okay, so everything known, and we can simply find that delta, and it will come out to be around 30.7 degrees or 31 degrees. Okay, so this is how you can just think about the problem, use these formulas and try and solve them. It's quite easy, interesting, as well as quite insightful questions. Okay. So now here we have another problem which is again very interesting. So pay attention. It says that we have a prism with a very small angle. Okay, so small angle. Small refractive angle 4 degrees. A ray of light is coming like this, getting deviated, hitting a mirror, right? And then it is getting reflected. So certainly this is going to be I and this is going to be I, that we know. Now the question is, at what angle we should rotate the mirror such that the ray of light is parallel to the base. Okay. So this problem, when you think about it, has two parts, right? The first, you have to find this deviation, okay, and then you have to find an angle through which this angle A, right, through which the mirror has to be rotated so the ray of light become parallel, right? So let's start by finding deviation. Now remember, in our last video we said that whenever we have a small angle, right, small angle theta, when the theta is very very small, right, the apex angle, the refracting angle of the prism is small, we can simply write the deviation delta is going to be equal to n minus 1 and into the apex angle theta. Okay, remember this. So for all the small angle problems, you can simply straight away use this equation, very handy. Also, sorry, the n is given here 1.5. Okay, plug that in here and we'll know our deviation. Deviation is going to be 1.5 minus 1 and into 4 degrees. This is going to be equal to 0.5 into 4 degrees, 2 degrees. So deviation is 2 degrees, right? Now we need to find out that how much, by what angle we should rotate so that it comes in a straight line. That is also very simple. If you just sort of draw this, so this is delta and it has to be horizontal, right? So the final is coming like this, hitting the mirror and becoming horizontal. So this one is parallel, so this is also going to be delta, right? So this one is going to be the angle of rotation. So if you just rotate the mirror by delta by 2, it will reflect the light by delta, that we know, and we did one problem like that also, right? So the angle of rotation for the mirror is going to be delta by 2, this is 2 degrees by 2, and this is going to be 1 degree. Okay, so this is a combination of mirror and prism problem, quite easy, quite handy, easier to do. So let's move to the next question, which is also conceptual, and if you have your hopefully the fundamentals clear by now, you'll be able to solve it pretty easily in no time, right? So now here we go. A given ray of light suffers minimum deviation. Remember, suffering minimum deviation in the equilateral prism P, which is this one. Additionally, prism Q and R of identical shape and of the same material P are now added as shown in the figure. The ray will now suffer greater deviation, lower deviation, like that, right? First thing first, when we said in case of minimum deviation, right, the ray of light coming like this always pass parallel to the base. Okay, the ray is going to be like this, right, and this is our deviation. Now, this prism is of same refractive index, so no refraction will happen here. Pass straight parallel. This one is also same refractive index, so no refraction will happen here. Pass parallel, right, and then the reflection will happen. So what it means is that the ray of light, because it's passing parallel, there is going to be no change in the deviation, and so the answer is same deviation as before. Okay, because earlier this deviation was this angle, right? Now it is again the same, right? Because it's passing just parallel to this thing. So the answer is C, same deviation as before. So that was our problem set for finding deviation through prism. This is a very important concept. Try and practice few problems if you can find, or we'll provide it for you, and then you will be able to solve these problems quite often asked in exam. Video we'll watch solving more problems on critical angle and total internal reflection. Until then, good luck and goodbye.